I generally dislike making user interfaces, as most of my friends really know. So in this case, I unfortunately had little choice. I might have gone a bit too far with this. So I spent well over a year, which is a long time, getting my lathe to work right. It was a long time, but it was very worth it. Now I wanted to run a job on the machine, and it was extremely confusing and unsatisfying. So I wanted to move left at some point, so the X is the Z, I think, so I have to do, I think this one. Oh, no, the other way, back, and then go down a bit, so that's the minus X, and the tailstock should move, I don't know. No, this isn't it. Let's just run a job. Yeah, so run this one, I think. Oh, no, wrong. Well, that happened. So one might wonder what makes a lathe so different. So let me quickly explain this. So if you have a mill, you have a XY table, and you put on a piece of work there, and then you have your mill, and it will come down and it will go in this direction and this direction, and this tool will go down and up. So this is relatively simple because you have just one tool and it will just cut everything away, and you have to zero it at some point, so let's say here normally, and then it will just do its thing. So for a lathe, this works differently. We have a motor with a chuck, then you have a tool turret with some tool, and you might have some tailstock, which is something like this. So your material is typically here, and you're cutting it with a tool. Now this tool is usually in a tool changer or a quick changer or whatever you will call it, but it's pretty much always the same offset and the same length. So once you load your tool, you actually know where it is, because the thing is pretty repeatable. Now, for a normal mill, the x-axis is here, the y-axis is here, and the z-axis is here. Well, for a lathe, for some weird reason, they call this the x-axis and this the z-axis. So if you're using the standard WebUI, you constantly have to think about where your Z and your X is. And you constantly have to make sure that you're not crashing something where it doesn't belong. So normally the tailstock is called the Z2 axis if you have a motor on it. So the Z2 axis will move up to the stock, and then it will clamp the stock down. So this is particularly important for things like wood, because the chuck will otherwise get loose, and then your wood will go flying. So the next thing you should notice here is that there's actually two things that can collide and that can work here, because your Z-axis has a tool, which is this, tool 1, and your tool holder here also has a tool, which is tool 2, and they can be installed at the same time. Well, on a mill, you can only have one tool here, tool, right? So that's another difference. So, and the third difference here is here you can't ever have a situation where one of the axes is interfering with the other axis. Well, in this case, if you have, say, the tailstock here, and the tool here, and you're going to run there, and then it will interfere and it will cause a crash. So on a positive, lathes are also very predictable. And what I mean with that is that the center line, which is the dotted line here, runs right through the tailstock and through the chuck to the middle of it, is what we call x is 0. So there's a second point here that's pretty important, and that's the front of the chuck here, which is usually some z value that you know beforehand, and it's never going to change because your chuck is never going to change. So if you know where this point is and you know where the x is 0 is, you pretty much know everything except for the length of the stock here. So if only we had a tool to measure the length of the stock, then we would know everything and we can just hit run once we press the job, right? Now if I'm going to make a user interface, I might as well make one that best fits my personal workflow. So before explaining the UI, let me briefly explain the workflow. First thing we'll address in my workflow is how much effort I'd like to put into running jobs, which is basically none. Ideally, I want to just put stock in quickly, post-process the toolpaths and hit run. So then I want to sit on my couch, sip coffee and then watch it do its thing. Which is here, like there, or perhaps there. Now, most of these lathe things are pretty heavy. I mean, you have a chuck here, which weighs, I think, 1 kilogram or something like this, and this isn't a really heavy chuck. You're going to put stock in here. This is just a little bit of stock, but yeah, I can imagine just putting, I don't know, 50, 60, 70 centimeters of steel in here. So if things are going to go flying, I really don't want to be here, standing here, because this is a pretty short distance, and if I'm just making a point here, I don't know, something like this, then I'm going to get seriously hurt. So I'd rather be somewhere else, like, I don't know, on my couch. And put a camera on top of it, and if things go south, just, I don't know, watch it burn from a distance. Now I do realize that these things have an emergency stop for a reason, which is obviously accessible, so you can easily just hit it when it's needed. Now I've always really enjoyed looking at the toolpaths in Candle. When browsing through the G-code, you can see what happens, and when the machine is running, you can always see how long it takes to complete. So I figured I wanted something like that as well. So let me just quickly do a demo here. I have a tool of 23 millimeters, or a toolpath that requires more than 21 millimeters. So I say it's, I don't know, 20, oh no, that's too short. 23 millimeters, apply G92 and press run. Before I do that, you can actually see here what the toolpath is. It renders like this, and you can see here what will happen in the machine and as the stock is removed. So when I press run now, it will start running that, and you can actually see what's going on in your machine right from the couch, the way I want it. And I can really look at this for hours. Right. Stop. So when I stop this, I obviously can resume again, and that way if things go wrong and I hear a wrong sound, I can just press the E-stop or the stop there, unlock it, browse to a safe location and start and continue where I left off. But something is still unsatisfying here. I wanted to know if my machine is going to get into trouble before actually running the toolpath. Now for lathes, there's something called the material removal rate. So basically this is how it works. So you have your stock and you have your tool, and it's going to remove a piece here. So The amount of material that's removed here is easily calculated by the rate of your spindle, the diameter that you're lathing, because if you go farther to the outside, then your stock is going to spin faster, so diameter. And how much you're cutting. And of course the tool. Now most of the better manufacturers have a table at the back of their tools, which actually explains what the material removal rate per revolution or per what the speed should be. So if you look here, it says, let's see, 0.18 millimeter per revolution and 200 meter per minute SFM, right? So if you can just put in these values, then you know that the tool is going to work like it should be. So these tools, as many other videos explain, have a, oh, here we go, have a little chip breaker here, which you can probably see. So what happens is the material goes down here and it's going to curl, but because there's a little indent there, it's going to break off and create nice chips. So that's exactly what we want. So the material removal rate here actually says a lot, because it will tell you how fast your machine is going to go. It will tell you if your tools are going to cut properly, and it will tell you if things are going to break. So what I really wanted is to have this material removal rate in the user interface for my toolpath, so that I can just inspect it and see if things are going to go wrong before I actually start the job. It's just not a safety feature. So this is a toolpath with constant spindle speed, and if I put in the numbers like 60 millimeter diameter, which is correct for this piece of stock, I can see that the material removal rate is going down, which makes sense for this toolpath. So one thing I noticed, that if the material removal rate is 0 with the parameters you entered, then it means that it can be a rapid move. So for a lathe, it's pretty clear when you can optimize something. I do use a bit of clearance here to make sure we don't accidentally bump into the stock. But basically what I can do now is just commit it, and it will create an optimized G-code file. And as you can see here in the toolpath view, it's all rapids now. And we've gone down in time. So then I went back to jogging, which is where it all started, right? So I figured if I have a lathe, I have, I don't know, this thing can go, is a chuck, and it's the same position, and then I have this thing, and then I needed a dial here so that I can move this thing, and I needed another dial to move this thing. Oh, it's very confusing. So instead of doing all this, I just thought, oh, why we live in 2025? Why don't we just make a square on our screen and make it touchable? And I want to just go here. So I'm going to touch there. It'll draw the toolpath and it'll just go there. I really felt that the X and Z were very confusing. So instead of doing it like the usual way, I decided to just do it like this. So here's a pane that you can just click, and you can go everywhere here that you would like. And it will just, I don't know, move there. And you click go. So here we go. You can zoom in. And you can zoom out, and the work envelope that you can go matches the work envelope that you can actually travel. So I think this is better than just doing it with jogging wheels and other confusing things. And I've made a little sketch of what the toolpath will look like, just to give you an impression of where stuff is. And yeah, I think this works reasonably well. So I went ahead here and made a configuration for a tool table. You can basically just enter all the information you need, or just select them and configure them the way it should be. So I think I have a SCR, LCR tool, whatever that might be, and it's 60, I think. Well, it looks like that. Yeah, that looks right. So all this information can be deduced from the ISO codes, and all of this information is usually available at the vendors. And next to this is the offset information. So you typically want to probe this by putting a little probe in your spindle and then entering the information here. Something still felt incomplete. Specifically for a lathe, it might even be useful not to go through a CAD-CAM every time. So often you just want to reduce the diameter of something or make a little thread. The need to go through a complete post-processor for simple things like that doesn't feel like it fits my favorite workflow at all. So I ended up making a little CAM process here, and I can just roughly show what it should look like. I don't know, thread pitch 1, something like that. And then we can do CAM. And it will generate a toolpath like that. And we can just save it and run it if we want. So this is very much a work in progress, this isn't done yet. But you get the idea what I'm aiming at. And because turning is often the same, or not, because turning is so predictable, you just want to, I don't know, make this in the default workflow instead of going to CAD-CAM every time. So yeah, so there you have it. That was my stab at making a lathe user interface. Just tell me what you think of it and if I need improvements in the comments below. And otherwise I'll just go back to my couch and do important things. Cheers!